distribution, which is really a change in the distribution of traits or the frequency of given genes in a population.
Are there any styles to live?
Yes. So that's what evolution is. It's a change in the distribution of traits, a change in the frequency of genes. What causes those changes? What's the mechanism that causes this to happen? Ah, that's it! I knew I remembered that. We've talked about this before. We have? We have. We have. The mechanism that causes these changes to occur, the mechanism that shifts distributions, is natural selection. That's the mechanism. I'm just going to run down a quick review because we've talked about this before. There are 4 main points. There are 4 assumptions that go into the theory of natural selection. Number 1, everybody's different. Everybody's a little different. Everybody is different. You're different, I'm different. Looking at a population of, say, rabbits in my neighborhood, Stumpy's different. Stumpy Jr. and Stumpy Jr. number 2 are different. Everyone is a little bit different. And in addition to everybody being a little bit different, life is tough. The environment presents challenges to survival and reproduction. Life is tough. What challenge did the clipbirds face? Well, what was the challenge? Is there an automatic food? Getting enough calories. Not dying. Hank, the guy from the Crash Course videos, we watch a few of those over the course of the year. Hank says biology is about sex and not dying. It's kind of true. The clipbirds needed to get enough calories to reproduce. They wanted to make sure their babies got enough calories to stay alive. The environment presents challenges to survival and reproduction. That challenge might be a predator. It might be just the basics of getting enough food. It might be a disease. But everybody's a little bit different, and then life is tough. Individuals tend to produce more offspring than will survive. Many will die. I just like saying as though it's like some horrible action movie trailer. Individuals tend to produce more offspring than survive. If Stumpy has 8 babies, what are the odds that all 8 of those babies are going to go on to adulthood and survive and reproduce? Pretty slim. Pretty slim. Those babies might meet a neighborhood cat. They might meet my dog. They might meet a car. They might meet a lawnmower. They might meet a disease. They might just starve to death. Life is hard. And there tend to be a lot more offspring born than will actually survive. Many will die. And then the last one that I don't have a clever three-word summation for. Individuals with mutations or features that have some advantage for survival tend to pass on more of their genes. Do you guys have a good 3-word summary for that one? There's the one that we commonly hear, survival of the fittest. But here's the problem I have with that. It sounds like the one who can do the most pull-ups wins. The one who can run a 4-minute mile. That's not the kind of fit we're talking about. That's what it sounds like. It means the one who's the best fit for their environment. So if it gets really, really cold, and the summers are cold and the winters are even colder, Stumpy might be a great fit. But if our climate suddenly shifts in the other direction and we have 110-degree summers and 90-degree winters, Stumpy is not going to be able to maintain homeostasis. Stumpy will die. Do you have a good 3-word summation? Is that what you're talking about? Individuals, the fittest survive. The best fit survives. The one with an advantage survives. That's the mechanism of evolution. It's natural selection. Where have we seen this before? Clipbirds, yeah. What was the variation? Beak size. What was the big challenge? Getting enough calories. Who was able to get enough calories? Birds whose beaks were a good fit for the food that was available. Who and their offspring got enough calories to survive? The birds that had a beak that was a good fit for the food that was available. Yeah, okay. Where else have we seen this? I feel like we've talked about this before. What were we really talking about in the beginning of the year? Yeah, we were talking about evolution. That's what antibiotic resistance in bacteria is. So, are all bacteria identical? No. We get some that have, differences in their protein synthesis mechanism or slightly different coding, those gram negatives. Everyone's a little different. They're not all identical. Is life tough for bacteria? Yes. I'm going to put all 4 of them up on at once. Yeah, we're actively trying to kill them. Your immune system is probably killing bacteria right now. There are little white blood cells that are streaming through your body, eating bacteria that could cause you harm. We cook our meat to 165 degrees, ground beef, to kill bacteria. We do this horrible thing of putting chemicals in your body to kill bacteria. Life is tough. Life is tough. Do bacteria make as many babies as they possibly can? Of course they do! They just keep dividing, and dividing, and dividing, and dividing, and dividing. Many will die. They make a lot more offspring than they think will survive. And who survives? The ones who have some difference that allows them to survive. That's the 4 points of natural selection right there. Everybody's a little different. Life is tough. Many will die. Best fit survive. That is natural selection. And this is, I didn't plan it this way, but boy, this works out with the whole anti-bullying day, unity day thing. Because sometimes I'm a little bit cynical about stuff like that, but I will say this. From a biological perspective, from a scientific perspective, variation is not something to be tolerated. It's not. Variation should be actively celebrated. Do you know why? Because guess what happens when everybody's identical? They all respond to a challenge the same way. So in the case of those clipbirds, if everybody's beak was identical and your food source, the only food source you could eat, disappeared, guess what happens? You all die! You all die! I'm into like horror movie trailer noises today, I guess. It's always fun to like just hit random play in my brain and see what comes out. If every organism in a population of bacteria is identical and they get hit with a bacteria, what happens to them all? A bacteria that works against them. They all die. So apparently you guys have talked about the Black Plague at some point in your academic career? Bubonic plague? Who's talked about bubonic plague at some point in their academic career? Okay, so you may have figured out that I really love the disgusting bits of biology. I'm a biologist. I think the disgusting stuff is cool. So why was it called the Black Plague? Go for it.
People got like a disease or like
it was an infection, all right.
and like their skin broke out and like it turned black.
Black pussy boils called buboes. Yeah, we said the word pus about 15 times in 5th period, and those poor people have me right before lunch. You're lucky you have me after lunch. Black pussy blood-filled boils that erupted in the armpits, groin, and around the neck. They were called buboes, hence bubonic plague. Ew! Transmitted by fleas, yeah? What percentage of Europe did it kill? I want to say 1,400. Am I right? I don't know. I have to look that up. I forgot to look that up at lunch. What percentage of Europe did it kill? Something like 75%. Like 3 in 4 people died. Do I have that backwards? Was it 25% or 75%? I think it might have been. Hold on. It kills half the population of Europe. Why doesn't it kill the other half? They may have some variation in their immune system that makes them more susceptible. I mean, maybe they got lucky. Maybe they were living in an isolated cave because they were a hermit and they didn't speak to anyone or have fleas, which is unlikely because most people in the Middle Ages in Europe had fleas actively at any given time. But yeah, maybe they got lucky, but maybe they had some variation in their immune system that allowed them to survive. Yay! That's fantastic. Who here, what year was it? 2009 or 10? You guys would have been in like elementary school, yes? 2010 elementary, swine flu, the big swine flu outbreak. Yes, it was 2010. I had kids who had never missed a day of school. I had a kid who had perfect attendance up until his 11th grade year. He was out for 5 days in a row. He was completely freaking out because he had swine flu. He was like miserable. He thought he was, he was like laying flat on his back, aching is what he told me, and feverish and delirious and miserable. It swept through. People were out all over the place. Why didn't everybody get it? Some people probably got a flu shot that protected them. Why else? Variations in immune response. Ebola. 3 years ago. We talked a lot about Ebola in biology that year. What is Ebola? More disgusting diseases from Moser's treasure trove of disgusting diseases. It's a hemorrhagic fever. What does hemorrhage mean? Bleeding. It's a hemorrhagic fever because as it destroys the intestine, there's massive bloody diarrhea, and as tissues in the body break down, there's often bleeding, sometimes bleeding from the eyes, sometimes bleeding from the mouth, and it's horrible. It's a horrible way to die. It swept through West Africa about 3 years ago. Sierra Leone was particularly hard hit, a couple other countries on the West African coast, and there were some villages where it killed like 9 out of 10 people. There were also people who contracted Ebola and survived. Whoa. What does that mean? Does it mean that perhaps they had some immune variation which allowed them to survive something that was deadly to most people? Possibly. We don't really know. Variation is not just to be tolerated. My God, it's fantastic. If we're all the same, then all the same things kill us all. What were the clipbird's choices when the food changed? Could you think yourself into a bigger beak? No. If you couldn't deal with the environment, what happens? You die. You're done. If you've got variation in a population, it means that somebody survives. Somebody carries on the species. That's kind of important. I don't know. Some days I think I'm rooting for our species. Where else do we see natural variation? These are finches. These are called Darwin's finches in honor of this guy, Charles Darwin, who traveled to these islands. These are the Galapagos. They're off the coast of South America. And he found all these birds on all these islands that look just a little bit different from one another. There's a great little textbook blurb in your book if you're interested in reading about them. Basically, the environment on these islands was slightly different. And so over many generations, these birds began to evolve in different ways. This is natural selection. Nobody went in and picked them. Now, can we go in and pick traits? Can we go in and pick traits in an organism? Who here has bred dogs? Okay. Who here has been to a pet store where they have little purebred dogs? Did those traits evolve naturally as a result of natural selection? Heck no. What is it, the pugs that have like constant chronic respiratory infections and respiratory issues because their face looks like they kissed a Mack truck at high speed? Their entire nasal cavity is shoved up like this. And so they're walking, my neighbors have a pug waiting down the street. Disgusting. Oh, God. I mean, they may be cute, but the snot and the nasal infections and the early deaths from pneumonia because they can't clear the bacteria out of their nasal passages. And dogs have got like really intense nasal passages because they do a lot of navigation by smell. Yikes. They got issues. You know, I got issues. We all got issues. But they got serious nasal issues. I mean, you've got breeds that have been selected who have had traits selected. What's that called when we select traits, when you and I select traits by breeding versus, it's not natural selection, it's artificial selection. There are traits that have been selected artificially that would never make it in the wild. Never. For instance, which breed is it that can't give birth naturally? There's a breed that almost always the pure, which is it? Is it bulldogs? They generally cannot deliver puppies naturally because the breed has been selected for narrow hips and giant heads. That doesn't work. That's death. You know, left to their own devices. There are other, well, turkeys. Who here has ever eaten a turkey? Has anybody here ever raised turkeys? Yes, I love raising turkeys. And turkeys come in two varieties. Well, they come in more than that, but you have your natural turkeys, like wild turkeys that you might see out on the road, and your heirloom breeds, and they're kind of narrow and tall and skinny. And then you have broad-breasted whites who cannot mate naturally. Do you know why they cannot mate naturally? It doesn't reach. Now, mind you, birds don't have penises, so it's not that the penis doesn't reach. Birds do what's called the cloacal kiss. It's two little openings. They line them up. Sperm is exchanged, male to the female, and then the eggs are fertilized. But in yeah, it's kind of weird. They don't have a true penis. But in broad-breasted turkeys, there is so much muscle in front, because that's that nice, delicious turkey breast that we like to carve on Thanksgiving, that the male cannot successfully mount the female, and they're all created via artificial insemination. We have artificially selected for a trait which could not exist in nature. It can be done. But left to their own devices, there would not be any more broad-breasted turkeys. They can't make any more on their own. Natural selection. Natural selection is where we're looking at species. We're looking at changes in the distribution of a population, changes in the gene frequency that have an advantage. Changes in the distribution of a characteristic in a population that have an advantage. Now, interestingly enough, because, you know, Moser's disgusting parade of horror, because I like this stuff. I always like the gross parts of biology. Because I think I'm like a 12-year-old boy at heart. So, like, the grosser, slimier, more disgusting it is, the more I'm like, cool! Oh, well. Diseases like Ebola, like the Black Death, the bubonic plague. You know what happens to them over time, typically? They evolve. Syphilis. Who knows what syphilis is? What is it? It's a sexually transmitted infection, right? They used to say STD, now they say STI. Sexually transmitted infection. It has really no outward symptoms for about 20 years. Up until yeah, how's that one for scary? Up until the 1970s, I think, in the state of Ohio, you had to have a syphilis test to get a marriage license because there had been cases of people who had undiagnosed syphilis and passed it to spouses and passed it to multiple children. And it was incurable. I think it's curable now with antibiotic treatment. I'm not sure. I'd have to check that. But, you know, you can't treat something unless you know you have it. And so it's symptomless until about 20 years in when people go blind and crazy. Yeah, not good. Not good. I mean, it does damage, but it's slow. Here's the interesting part. Descriptions of patients with syphilis in the 17th century, so we're talking like 1600, describe people with like green and yellow lesions on their skin and pus-filled boils all over their faces and their bodies. Let that sink in for a moment. Somebody who looks like they're decaying and is covered in pus-filled boils. Okay, wait a second. How is this transmitted? Sexually! Do you think a lot of people who are covered in green lesions and pus-filled boils are going to transmit this infection, to put it delicately? No, not so much. Not big candidates for a hot Friday night date. The infection does not get transmitted. What does a syphilis patient look like 400 years later? Like nothing's wrong. That is the evolution of the disease. That is the evolution of the pathogen. A pathogen is an agent that causes disease. Because how does the pathogen get transmitted? The pathogen has to get transmitted in order to survive. What happens to a pathogen that, achoo, you catch and then you immediately drop over dead? What happens to that pathogen? Does it get transmitted? You drop over dead. You're dead where you fall. Are you going to be able to transmit that pathogen to the next victim? Ow, I kind of hurt my head doing that. No, because you're dead. You're right there. You're not going anyplace. You're not, achoo, sneezing on people. You're not touching their stuff. You're not spreading the pathogen. Pathogens over time tend to become more transmissible. Achoo! 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 Easier to transmit, more transmissible, and less virulent. What does virulent mean? Deadly. Over time, infections tend to become more transmissible and less virulent. Why? Think about it from the pathogen's perspective for a minute. Yeah?
Wait, if you have it
Sure. Sure, eventually. But it's in the bacteria or the virus's best interest to keep you alive and walking around as long as possible. Because the longer you're walking around, achoo, 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 the farther you're spreading that thing. It's not in the pathogen's interest to kill you fast. It's in the pathogen's interest that you stay alive for a while and pass that stuff around, however it's transmitted. So over time, we tend to see natural selection favoring pathogens that are more transmissible, achoo, more easily transmitted. So things can go from being, strictly blood or bodily fluid borne to being, achoo, something that's airborne. That was one of the big nightmares about Ebola. When they were 3 years ago, when there was the big flare-up of Ebola in West Africa. So at that point, Ebola was transmitted only by blood and bodily fluids. One of the big concerns was, could the virus mutate to be airborne? Like the flu, like a cold, where it will survive on droplets of mucus or, vapor from a cough long enough to affect someone else. Thus far, there's no evidence that Ebola did become airborne, which is really good because it's a really horrible disease. But there is also evidence that from the first outbreaks of Ebola, which were documented in the, I want to say 1950s in Central Africa, that from those first outbreaks, Ebola has become less virulent. It kills fewer of its victims and kills them more slowly. Because which viruses get to pass on their genes, or which bacteria get to pass on their genes? The ones that left their host alive a little bit longer. Achoo. Achoo. Which bacteria get to pass on their genes? The ones that were able to resist that antibiotic. So natural selection changes the distribution of characteristics in a population, and you always have to think about what gives an organism an advantage. And I got an opportunity to talk about Black Death, so I'm a happy person today. Okay, a few little bits of review on mechanisms here. What we later come to think of as adaptations, having a large beak and living on an island where all your food is big. That's an adaptation. Often start off as a mutation that underlies variation. When something gives you an advantage, those genes get passed on with greater frequency. And generally, the shifts in characteristics are a response to conditions in the environment. There's a big food source, big beaked birds are advantaged. Little beaked birds die. It all depends on what the environment rewards. So tomorrow, when you come in, we will have a test, quiz. We will have 30 minutes together, which should be more than enough time for you to finish that. If anybody finds after 30 minutes that they do need more time, I will happily write passes for 7th period. That's not a problem. You guys get to sleep in tomorrow, which is a wonderful thing. Now, here's the favor I have to ask you personally. Go to bed at a reasonable time anyway.